All right, so this will be an interesting exercise. What I'm going to do is compare different measuring devices we're going to measure the mass of the same thing, except we're going to have different measuring devices. So I just turned on the digital meter. This is a very precise one. It's precise to within 0.0001 grams or milligram. And we're going to measure the mass of these things. Now, the stamped, this is actually 50 grams. It says 50 grams right on the base. You see that? So ideally, it'll be exactly 50 grams. Oops, there we go. You can see it says 50 grams. So that's the stamped value, 50 grams. So the stamped value for this hanger is 50 grams. What I'm going to do is put it on my scale and see what it reads. Does it read exactly 50 grams? No. It reads, so this is the digital scale. The digital scale will read 48.633 grams. So it's supposed to be 50 grams. It says it's 50 grams, but it's a little less. So these things are manufactured in mass, and sometimes they lose a little weight over time. Sometimes they gain a little weight. It really depends. So anyway, so that's the mass of the hanger. Now what we're going to do is try to measure its mass two more ways. So we've got the stamped mass, 50 grams. We've got the digital scale, which is calibrated, so that should be fairly good. And then we have this is a spring scale. So what I'm going to do first is I'm going to calibrate this thing. I'm going to hang it. Do you see how it doesn't exactly read at 0 here? So this thing moves up and down, the scale. So what you do is you just sort of move the 0 to where it's at 0. There's a spring inside. There's actually just a spring. You can see the spring through the clear wrap thing. And over time, the spring goes kind of crazy. So what I'm going to do is I'm going to hang the mass hanger on the spring, and we are going to measure its mass. Okay, so this has got newtons and grams on it, so let's measure it in grams. So how do we measure it? It's less than 100 grams. It's a little tiny bit more than 50 grams. So it looks like it's between 50, it's a little more. I'd say like 52 grams. I mean, that would be my best guess. So again, for the VWR scale, I'm just going to call it the VWR scale. It's like, what, 51 grams I'm going to put down? And notice the precision of this is only plus or minus 1 gram, so it's much less precise than the digital scale. And you can see that, again, all three of them so far are different. Now the last method I'm going to use is the OHA scale. So it's another spring scale. You can't see the spring, it's inside. So if I hold it up like that, you can see that it's not reading at 0. Well, it's reading close to 0, but not quite. So I'm going to grab it and move it slightly over that way. Let's see if that's better. Yeah, it's a little better, but still. All right, it's much better. So the same way, I am going to grab it with this, and we're going to read off what it says. Now, in this case, it reads off in newtons. So we're going to have to convert this to mass. This is not a mass scale. This just measures force. So how do we measure it? It's between 0.5 and so this is more precise than the last spring scale. So it's between 0.5 and 0.6 newtons. It's 0.55 newtons. Okay, so let's look at all of those measurements here. We've got OHAS is 0.55 newtons. So what does that mean? Okay, a newton is a unit of force. The gravitational acceleration is 9.8 meters per second squared. So we're going to get to this later in class, but to try and figure out how to get from force to mass, what you do is you take the force and you divide by the acceleration. So we've got the force, 0.55, divided by 9.8 will give you the mass, and in this case it'll be the mass in kilograms because newtons is an MKS unit. meters, kilograms, and seconds. So 0.056 kilograms. And that's equal to 56 grams. So according to the OHA scale, is 56 grams. VWR, 51 grams. Digital scale, 48.633, and stamped mass is 50. So can you see a problem when you're doing stuff in lab? If you just rely on what it says it's stamped on there, 50 grams, how are you going to know if, okay, it's approximately right, but it really depends on what particular measuring device you use. Now, the digital scale has been recently calibrated, so this is probably very close to the actual value. But, maybe in the last 6 months, it's gotten a little miscalibrated. And you can see the spring scales are quite a bit off, especially the OHA scale. It's like off by quite a bit. So which one is the accurate one? The most precise one is the digital scale. The least precise one would be the stamped is 50 grams. It's only one, it's like plus or minus a gram. This is also plus or minus a gram. So these three all have pretty much the same precision, which is not very good. But precision is not the same thing as accuracy. Accuracy is how close you are, the measured value is to the actual value. So how in the world would we go about figuring out which one of these is the best one? Well, we have to get a calibrated mass. And I'm going to put the calibrated mass on the digital scale, and we're going to see how close the digital scale gets, because that's the one that's probably going to be closer to the actual value. If the digital scale is calibrated, then we know that the digital scale is the best one to use.